Welcome all to our second RACE Summit. In this talk, I will make 3 points. First, distributed applications are becoming the norm rather than the exception. Second, developing distributed applications is really hard. Finally, Ray and Anyscale make developing, deploying, and managing distributed applications easier than ever before. One of the main reasons of why distributed applications are becoming the norm is down to 2 trends. The first is that applications are increasingly incorporating AI functionality. Indeed, we now see AI making its way in virtually every industry: finance, manufacturing, transportation, hospitality, healthcare, and more. The reason of why AI workloads are becoming distributed is simply because the demand of these workloads are growing much faster than the hardware capabilities of a single processor or a single node. During my last summit talk, I showed you this plot from OpenAI that shows the growth of the compute requirements to train the state-of-the-art models between 2012 and 2019. The growth rate was staggering, 35 times every 18 months. For comparison, according to the Moore's law, which powered the tech industry for decades, the processing performance only doubled every 18 months. This is a huge gap. Now, almost 1 year later, let me add another data point showing the GPT-3 training requirements. As you know, GPT-3 has 175 million parameters, and it is the largest model released by OpenAI so far. As you can see, the rate of growth has continued unabated. During the same time, there are no breakthroughs to reverse the decline of the Moore's law. So, per core CPU performance is still increasing by just few percent per year. And while the performance of specialized hardware has continued to grow at an impressive rate, it is no match for the increase in the demand. As such, to support these workloads, there is no other way than distributing these workloads. Unfortunately, building distributed applications, in particular AI applications, is very hard. There are 2 reasons for this. First, the applications are becoming more and more complex. Second, not only developing but moving distributed applications to production is very difficult. Next, I'm going to use 3 examples to illustrate the complexity of these applications: online learning, reinforcement learning, and back-end applications that combine business logic and inference. I will then argue that today there is no framework to implement such applications end-to-end, and so the developers are left with little choice but stitching together a bunch of disparate frameworks. The first pattern is online learning. Consider a mobile application in which you want to recommend the users the products from our affiliates. And we want these recommendations to take into account rapidly changing users' preferences. For example, when a new product is launched, we want to rapidly figure out who has bought the product so we can immediately recommend the product to people most likely to buy it. At the high level, an online system consists of 3 stages: a data ingestion and featureization stage that preprocesses the logs from users. One example would be which offer did the user see and which offer did she click on. Then we have a training stage that uses the latest data to update the model. Finally, once the model is updated and tested, we push it to production. That is, to the serving stage. In general, we want to update the model frequently so that it captures the pattern changes in the most recent data. Today, there are really no system to implement online learning end-to-end. However, for each stage, we have highly scalable frameworks. For example, for data processing, we have Spark, Kafka, and Flink. For training, we have Horovod, distributed TensorFlow, and PyTorch distributed. And for serving, we have Seldon or TensorFlow serving. As such, the existing solution to implement online learning system end-to-end is to stitch together a bunch of disparate systems. Things can get even more complicated. For example, in general, we not only have to do training, but also hyperparameter tuning. Another workload example is reinforcement learning, which today is used in a growing number of applications, including industrial automation, self-driving, financial trading, and more. Reinforcement learning is even more complex, also requiring support for large-scale simulations. Again, one solution to build a reinforcement learning system is stitching together existing frameworks. One example here is Horizon, which was recently released by Facebook. A second solution is building specialized systems. Reinforcement learning powerhouses like DeepMind and OpenAI are building reinforcement learning systems from scratch, sometimes just to implement a single algorithm. Finally, we are seeing more and more a pattern that combines business logic and serving. This should come as no surprise. Virtually every backend today consists of a bunch of business logic and more some machine learning functionality. These systems are built today by stitching together some microservice frameworks to implement business logic and some serving systems like Seldon and TensorFlow serving to implement inference. So to summarize, today's AI applications are becoming more and more complex. And as AI is finding its way in virtually any applications, we very much expect this trend to continue. We are seeing two basic approaches to support these applications. The first is to build a system from scratch for a given workload. While this leads arguably to best performance, it is very expensive both in terms of time and people. As such, very few companies outside the Googles and the Facebook of the world can afford this. The second approach is to stitch together a bunch of disparate frameworks. Unfortunately, such solutions are hard to develop since each of these systems comes with its own API. They are hard to deploy and manage as each system has its own deployment process and its particular way to handle failures. And finally, they are slow, as in most cases, it is expensive to move the data between different systems, and each system stores the data in its own format. Ray provides a solution to this problem. Ray is a universal framework that allows the developers to build arbitrary distributed applications on top. As a result, it should come as no surprise that Ray has already a very strong ecosystem of scalable libraries. This enables developers to break the silos. Instead of stitching together a bunch of disparate systems, Ray provides libraries for these workloads. This allows the developers to use a single system, Ray, to implement virtually any end-to-end applications. Since the user needs to deal with a single system, such applications are much easier to develop, test, deploy, and manage. In addition, these applications are faster, as data can be exchanged between different libraries via arrays in memory object store. In the rest of this summit, you will hear several exciting talks about applications fitting these three patterns. Now, while Ray makes it easier to develop complex distributed applications, this is not enough. We not only need to develop this application, but also run them in production. Today, this is incredibly hard, even using Ray. To understand why is this, let us take a look at the application life cycles. There are two distinct stages: development and productions. During the development stage, we edit the code, then run it, and if there are bugs, we debug it and fix the bugs. Once we are satisfied, we merge the code and push the application to staging, where more tests are performed. If test fails, we go back and debug the code. If the test passes, the application is then deployed in production. Now, ideally, what a developer wants is to do her development on the laptop. Indeed, the vast majority of developers still do most of their work on their laptops, as they have access to a wealth of familiar yet powerful tools and frameworks. On the other hand, since these are distributed applications, they need to deploy these applications on a cluster or in the cloud. So the challenge here is how to cross this barrier between the laptop and the cluster. And this is a huge barrier. First, the developers cannot reproduce and test on her laptop the cluster deployment. Second, she also needs to take her application from the laptop and run it on the cluster. This requires her to package the application with all the dependencies and so on. Another possibility is to develop on the cloud. This removes the barrier between development and production, but unfortunately, this makes the development much harder. There are no good tools, in particular debugging tools. You also need to configure these clusters, and launching them can be very slow. Finally, using this cluster can be also expensive. With Anyscale, we dramatically simplify the development of distributed application and can seamlessly move from development to production. In a nutshell, Anyscale is a Ray-based hosted service that is secure, highly available, and provides tools for developing and deploying Ray applications. Anyscale provides best of both worlds. It provides the ease of development of your laptop and the scale of the cloud. With Anyscale, you can start developing on your laptop and seamlessly move to the cloud. This will be transparent to the user. It's like her laptop has now access to all resources in the cloud, but she can still use the same tools and development workflow as on her laptop. We call this the infinite laptop. How do we achieve this? Well, first, we automatically sync up local files to the cloud. Note that the new labels indicate the new Anyscale features we developed since the last summit. Second, we can take the code that ran on the laptop and run it on the cloud with no code changes. Consider the Ray code snippet on the left and the command line to run on your laptop. Now, to run this program on Anyscale in the cloud, you just need to use environment variables Ray address to point to Anyscale. That's all. No code changes. Third, Anyscale provides a serverless experience. As a user, you do not need to configure any cluster. Anyscale will automatically scale the infrastructure to run your applications. Finally, Anyscale provides you access to an interactive debugger, just like you have on your laptop. One of the most difficult steps in building a distributed application is going from development to production. There are 3 ways in which Anyscale simplifies this transition. First, it enables developers to easily package their applications. The users can specify all code and library dependencies, and under the hood, Anyscale builds Docker images to capture these dependencies. Second, it provides an SDK and REST API that makes it very easy for the developers to programmatically run a Ray application from anywhere. For example, from her continuous integration, continuous delivery pipeline. Finally, Anyscale provides dashboards like Grafana for users to easily monitor the deployment of their applications. Next, Edward Oakes, a technical lead manager at Anyscale, will demo the Anyscale features by showing how Ray and Anyscale can allow you to build distributed applications easier than ever before.